Today we're going to talk about derivatives and how to work with derivatives in a very basic way. So we're going to work with derivatives on power functions specifically today, and I'm going to give you a few rules to follow that will make this very simple. So, rules. The first rule whenever dealing with a derivative is to multiply your power down. So multiply your power down. And this will make more sense in a second. So let's just do a quick example of what this might look like. Say we have 2x and we're going to square it. So what I mean by that is we're going to take this square, we're going to multiply it down. So it's going to go straight down. 2 times 2 is 4. Keep your x, and then it'll go into our next rule, which this is not done, but rule number 2 will be decrease your power by 1. So what that's going to look like is this power was originally 2. Because we multiplied down gave us 4, we're going to subtract 1. So minus 1 here, which will give us just 1x. So this is the power for, or the derivative for 2x squared. So moving on to another rule here. Another rule is ease, or natural logs. We're going to work with both of those as well. Exponentials will always stay the same. So what that might look like is e to the, let's say 2. The derivative on this would be 2e squared. So the only difference was I multiplied my power down, but you do not decrease the powers on e. Okay, so let's just jump right into some examples. We'll take the derivatives of functions here. So let's go example number 1. We want to differentiate the function of f of x equals 5.2x plus 2.3. Now, we are differentiating in terms of x here. So this does not have an x, which means it's a constant. Whenever you have a constant in a function that is being differentiated, you leave it alone or it turns to 0. So because this isn't a variable, it's a number, it's going to go to 0. So if your constant is a number, it will equal 0. If it's a variable, it's just going to stay as that variable. So taking the next step of this has a power function of 1. So you essentially are multiplying by 1, which will leave us 5.2. Now 1 minus 1 up here, this will turn it to 0, which means x will actually go away, and this will turn to plus 0 because this is a number which will go to 0. So the answer is 5.2. Okay, so let's do another one here. Differentiate the function of f of t equals 2t cubed minus 3t squared minus 4t. So same thing, take each term as it comes. So multiply down, step 1. This will multiply down. We have nothing really here. Technically it's a 1, so we multiply down, but it'll just take the leading coefficient. So this will turn to 6t. You always subtract by 1 from the power, so you're multiplying down and then you're subtracting 1. So this will be squared. Keep your sign, because this is a positive times a negative will give us a negative. 2 times 3 will give us 6 as well. Keep your t. Now we're minusing 1 again. 2 minus 1 is just 1, so we can just leave the t. Minus again, we have 1 times 4, which is just 4. But we're minusing 1 again. 1 minus 1 is 0, which means our t actually goes away. So whenever you have a t by itself, so to the 1 power, it will just be its leading coefficient. So this is the answer for this one. Okay, moving to another one. We're going to go number 3. we're going to say f of r equals 5 over r cubed. Now don't let this freak you out, but really get in the habit of moving your denominators up. They're a lot easier to deal with when they're all in one line. So I'm going to rewrite this as 5r to the negative 3. So this equals this, so we can now go ahead and differentiate 5r to the negative 3. So this will give me, multiply our negative 3 down, negative 15, r. Now we are subtracting 1 still. So I have a negative 3 minus 1. This will bring it to a negative 4. So don't let that confuse you. You're still subtracting by 1 with a derivative. So you can leave it like this. Most professors will want you to clean it up a bit. So we have a negative 15. R is attached to the negative 4. Drop down your r. And that's going to be the answer for this one. Okay, so what happens when they ask for Leibniz notation? So Leibniz notation is something that you'll really want to understand well, especially if you are in Calculus 1 and you will be taking Calculus 2. It will save you a lot of work and headache. So Leibniz is essentially d over dx. Now what is happening here? This means the derivative with respects to x. So all that's telling you is you're taking the derivative of whatever function they've given you, and it's in terms of x. So any other variable that's not x, so if we had, let's say, 3x squared, we're going to multiply this all by 2, or n squared. So in this case, in terms of x, I am only differentiating the x terms. So this will give me, multiply your 2 down, 6x, 2 minus 1 for the power, which is just 6x, and n squared does not change because we are not differentiating in terms of n. So this is Leibniz notation, and it can get kind of confusing, but really try working with it. It will help you immensely in courses to come. So let's do a sneaky problem that will get a lot of students. I want you to differentiate the function of f of x e to the 5. Now, remember, e stays the same. So, whenever I had, for another example here, if I have differentiate 2e to the 3, well, same idea. This comes down, we multiply, so 6e, but we do not subtract off. It actually stays exactly the same. And I will explain that in another video, but just remember that you do multiply down, you do not subtract the power. So what would this function be right here? Well, this would actually equal 0. And the reason being is this is a function, we're taking the derivative in terms of x, and we do not have an x in this entire function, which means it is a constant, but it is a number, it's an exponential number. So it's not a variable. We wouldn't say e is e, it turns to 0. Because remember our rules, if we have 0, or if we have, a number, it's going to equal 0, and if we have a variable, it's going to equal that variable. So this would actually equal 0. So there are a few things to work on here. Just remember that you always are multiplying down. So step 1, always multiply down. Multiply down. Step 2, when taking a derivative, will be decrease your power by 1. And then do not forget about constants. What are we differentiating? It's going to be very important because they might try to trick you saying f of x or f of t in terms of t, and you might not have a t, or you could have a problem that has multiple variables. So if they said f of x equals 2x to the 4th minus 2x plus 2m. So I have an x and an m. This will not change. You are just differentiating what it's telling you to. I hope this helps. If you have any questions, please leave a comment below. I'll do my best to answer all of them. and I will be putting out some more videos on how to take basic derivatives. But until then,